Hello students, let us discuss some of the questions which is given in your textbook in the chapter Atoms and Molecules. Question number 1, page number 42. If 1 mole of carbon atoms weigh 12 grams, what is the mass in grams of 1 atom of carbon? As we have already discussed that the 1 mole of any atom, its mass is equal to gram atomic mass. So here the carbon having the mass, that is gram atomic mass, is equal to 12 gram. That is the mass of 1 mole of carbon atom. So what is the mass of 1 mole of carbon atom? That is 12 gram, which is given in the problem. So but we need to find out the mass of 1 atom of carbon. That we have to find out here. So we know that 1 mole of carbon atom means 6.022 into 10 raised to power 23 number of atoms. That is the definition we have learnt. 1 mole of any atom is equal to this much number of atom. So 12 gram is actually the mass of this much number of carbon atom. The mass is 12 gram. So the mass of this much number of particle is equal to 12 gram. So what will be the mass of 1 atom? So definitely how we do this one, that is 12 divided by 6.022 into 10 raised to 23. So when we solve this one, we'll be getting the value, that is 1.99 into 10 raised to power minus 23 gram. How it comes minus 23? Because when you divide this value, that is 12 divided by this 6.022, you will be getting 1.99. And here 10 raised to power 23 is in the denominator. But when you take it to the numerator side, the powers will get opposite. That means if it is having positive power, when it get into the numerator, it become negative. So that's why now when we are writing in the numerator, this value we are writing into 10 raised to power minus 23. What it means? That is 1 upon 10 raised to power 23. When it is taken to the numerator, that is equal to 10 raised to power. The number is as it is, but the thing is that here it is positive sign, but when you take it to the numerator, it will become negative. So that is the mass of 1 carbon atom is equal to 1.99 into 10 raised to power minus 23 gram. That is the mass of single carbon atom. But the mass of 1 mole of carbon atom is 12 gram. So you can find out the difference here. This is the mass of single carbon atom. It's very small number. But 12 gram is not a small number. That is the mass of this much number of particle. The mass is 12 gram. But the mass of 1 carbon atom is this value. Next problem. Which has more number of atoms? 100 grams of sodium or 100 gram of iron? Atomic mass is given here. So it is to be answered that which has more number of atoms. So we need to find out number of atoms means number of particles we need to find out. So 100 gram of sodium and 100 gram of iron. Atomic mass of sodium is 23 U. That means the molar mass, molar atomic mass, that is gram atomic mass, that is 23 gram. So 23 gram of sodium having this much number of particles. Why? Because 1 mole of sodium atom having this much number of particle and its mass is equal to gram atomic mass. Atomic mass is 23 U, gram atomic mass is 23 gram. So what is clear from this one? That is 23 gram of sodium having this much number of particles. So 1 gram will have how many particles? That is 6.022 divided by 23. That is the normal mathematical concept. So how much will be the 100 gram? So multiply with 100. So what we can do? 100 multiplied by 6.022 into 10 raised to 23 divided by 23. When we solve this one, we'll be getting this value. Let us find for the number of particles in 100 gram of iron. So what is the mass given for iron? Atomic mass is given 56 U. So what will be the gram atomic mass? That is 56 gram. So 56 gram of iron having this much of atom, because 1 mole of Fe having the mass 56 gram, number of particles 6.022 into 10 raised to power 23. So how much will be 1 gram will having? This divided by 56. That will be 1 gram of Fe will have this much number of particles. So how much will be the 100 gram? Now you have to multiply that with the 100. So what we got here, that is 100 multiplied by 6.022 into 10 raised to 23 divided by 56. When we solve this one, we'll get this value. Now compare the two values which have more number of atoms. That is this and this. So definitely the answer is sodium contain more number of atoms. Question number 7. That is a text exercise question. What is the mass of following? A, B, C is given. So let us find out this one. First one, A part, 1 mole of nitrogen atom. We have to find out the mass. What is given to us? Mole is given. So what is the relation of mass and mole? We know that 1 mole of atom, its mass is equal to, that is the mass of 1 mole of atom is equal to the gram atomic mass. That is gram atomic mass. So we are talking about the case of nitrogen. So nitrogen, 1 mole of nitrogen, what will be the gram atomic mass? That is atomic mass we are representing in U, gram atomic mass we are representing in grams. So that numerical value is same, that is the atomic mass we have learned the table for nitrogen, that is 14 U you have learned, but gram atomic mass we have to represent that in grams. So what will be the mass? That is 14 gram. So what is the answer for this one? That is the mass of 1 mole of nitrogen atom is equal to 14 gram. Next, 4 mole of aluminium atom. Here we have to find out for 4 moles. First let us find out the mass for 1 mole of aluminium atom. For 1 mole of aluminium atom, what is the mass? The mass is equal to its gram atomic mass. Gram atomic mass, that is equal to, what is the atomic mass for aluminium? The atomic mass for aluminium is 27. So 27 when we are representing in gram, that is gram atomic mass. So mass of 1 mole of aluminium is 27 gram. But in the question it is asked for 4 moles. So for 4 moles, what will be the mass? That is for 1 mole the mass is 27 gram. For 4 mole, that is 27 into 4. So that is equal to what? That is equal to, the answer is 108 grams. That is 27 into 4 is equal to 108 grams. So what is clear from this one? The mass of 1 mole of aluminium atom is 27 gram. That is the gram atomic mass. So for 1 mole it is 27 gram. So for 4 mole is equal to, that is 27 into 4. That is equal to 108 gram. Next one, 10 mole of sodium sulfide. Now it is not an atom, it is a molecule. It is a compound which is given sodium sulfide. We have to find out the mass for 10 moles of sodium sulfide. So we need to find out the molecular mass. Molecular mass or the molar mass, because values are same, only the difference is that the unit is different. So it is found, the molar mass is found in the same manner how we used to find out the molecular mass. So that is mass, atomic mass of sodium into 2, that is 23 into 2 Then sulfur, atomic mass for sulfur 32 plus into 3 into 16, that is 3 oxygen and 1 oxygen have 16 mass. So when we do this one, we'll be getting 126 gram. So 126 gram is the molar mass of sodium sulfide, that is 126 gram. So the mass of 1 mole of sodium sulfate is what? 126 gram. So what will be the mass for 10 moles? For 1 mole, the mass is this. So what will be the for 10 mole? So 10 mole is equal to, that is 126 into 10, that is equal to 1216. So that is the mass of 10 moles of sodium sulfide. Next question. Question number 8. Convert into mole. Now we have to find out the mole in 12 gram of oxygen. So we have learnt the formula, the relation of the mass and mole relation. What is that relation we have learned? Number of moles is equal to given mass by molar mass. This we have learnt. So what is given to us? 12 gram. So that means W is given to us, that is 12 gram. So 12 is given to us. What we need to find out? Number of moles we have to find out. This we have to find out. This one. M, N we have to find out. So molar mass, M, that is actually, we can find it out for oxygen gas. Oxygen gas means O2. We are talking about O2. So what is the molar mass for O2? That is 32 gram. So 12 divided by 32. So when we do this, we will be getting the answer, that is equal to 12 divided by 32 is equal to 0.375 mole. So better you can make the use of formula so that you will be getting the answer easily. Next, 20 gram of water. Again use the same formula. N is equal to W by capital M. Here in the place of W, we have already wrote small m. So you can write small m or W. Now what is given mass? Given mass is 20 gram of water. It is given in the question, 20 gram of water. 20 gram. What is capital M? That is a molar mass. We have learned that molar mass of water is 18 gram. If you want, you can solve this method. By this method, you can find 18 gram. So 20 divided by 18 gram. So when you solve this one, you will be getting the answer, that is 20 divided by 18 is equal to this much of mole. So make the use of formula. Very easily you can find out this answer. Next, 22 gram of carbon dioxide. Again use the same formula. N is equal to W, or you can use small m also, as we have done for the previous problems, by capital M. So what is given mass? Given mass is 22 gram. 22 gram is a given mass. Capital M, that is a molar mass. Molar mass for carbon dioxide is how much? That is, when we do this method, we will be getting 44 gram. So divided by 44 gram. So when you solve this one, you will be, that is 22 divided by 44 will be getting the value 0.5 mole. So this is the correct answer for the, that is the mole, number of moles in 22 gram of carbon dioxide is 0.5 mole. Next question. Question number 9. What is the mass of 0.2 mole of oxygen atom? Here again there is a need to find out the relation between mass and mole. What is that relation we have learned? That is N is equal to W by M. In the place of W, we can write small m also, as given in the textbook. So this relation we have to use for this problem. What is actually given to us? That is 0.2 mole of oxygen atom. That means mole is given to us. That means this value is given to us. N value is given to us. And molar mass is actually a known value. So what we have to find out here? We have to find out W. So rearrange this formula. So we'll be getting, that is W is equal to N into M, capital M. So W is equal to N into M. What is N here? N value is given to us, that is 0.2, and capital M, that is a molar mass because it is an atom. So we are taking, that is gram atomic mass. What is gram atomic mass for oxygen atom? That is 16. So when you solve this one, you will be getting the value of 3.2 gram. So that is the answer for this problem. That is 3.2 gram. 16 into 0.2, that is 3.2 gram. Next one also will be doing in the same manner. We'll be using the same formula, that is W is equal to N into capital M. So here N, number of mole is given 0.5 into 0.5 into capital M, because we are talking about water molecule. Water molecule, what is the molar mass? That is 18 gram. So when you solve this one, you will be getting the answer, that is 18 into 0.5 equal to 9 gram. That is the answer. So in this problem, we'll be using the formula, that is mass mole relation. That is, we are using this formula, N is equal to W by M. So you can make this formula in order to find out number of moles, in order to find out W. That is given mass. You can use this formula, just only you need to rearrange this one. Next problem, question number 10. Calculate the number of molecules of sulfur present in 16 gram of sodium sulfur. Here sulfur molecule means S8. S8 is a sulfur molecule. We have to find out number of molecules of sulfur 8 present in 16 gram. So here we have to find out number of particles. So what will be using the formula? That is, we have already learned a formula, that is number of moles is equal to given mass by molar mass. But we have to find out number of particles. So we have already learned a formula, that is number of moles is equal to the given number of particle divided by Avogadro number. So we have to find out capital N here. So what will be the N? N is equal to small n into Na, Avogadro number. We can make the use of this formula here, substitute the value. So that is capital N is equal to W by M into Na. Now we'll be using this formula, that is number of particles is equal to W by M into Na. So here what is W given to us? So that formula we will be using. So what is given W? That is 16 gram. 16 gram is the W, and Na value is 6.022 into 10 raised to 23. What is M? Capital M is a molar mass, that is 256. How we find out? That is the gram atomic mass for sulfur into 8. When we do this value, we'll be getting 256. So when we divide this one, we'll be getting the answer, this answer. So that is the method. In this problem, we are using the two formulas. Okay, so we are finding out the number of moles, and that value we are substituting in the formula for finding out the number of particles. Question number 11. Calculate the number of aluminium ions present in 0.051 gram of aluminium oxide. So here we have to find out the number of aluminium ions. That means number of Al3 plus ion present in aluminium oxide. Formula for aluminium oxide, Al2O3. So in one Al2O3, how many aluminium ion are there? That is 2 aluminium ion is present in 1 mole of Al2O3. So the molar mass will be getting 102 gram for aluminium oxide. So we can say that this much gram of aluminum oxide contain, that is 1 mole of aluminum oxide contain 2 into 6.022 into 10 raised to the power 23 aluminum ions. Why I am multiplying with 2 here? Because this molecule have 2 aluminum ions. So 1 mole of this molecule have 2 into 6.022 into 10 raised to the power 23 aluminum ion. So how much this gram will having? So this gram 0.051 gram will having this 2 into 6.022 into 10 raised to 23 divided by 102 gram into this value. So when we solve this one, we'll be getting the answer, that is this answer. So this is for the case where we are using the formula and we are finding out the number of aluminum ions. Single formula having that single aluminum oxide have 2. So we are multiplying with 2 here. So we are finding out this in the same manner how we have done for the previous problem. So this is all about the important problem related to mole concept in this chapter. Thank you.